Hi and welcome to today's video where we are going to be looking at combining like terms and a new concept called distributive property. So if you remember from a previous video that we did, we were talking about bringing things together, and when you look at a question like this, it can be very intimidating. And the idea behind math, particularly in this type of thing, is that even though we're dealing with a lot of numbers, it's really not all that complex of a problem if we just follow the canceling out rule or the rule of zero principle. And I'm going to show you what I mean in this video about how to do that. So first things first, what we should always do is we should try to get an understanding of what the question is asking. So in this case, it is saying that we've got a -3 outside of here, and then it's kind of hugging these brackets. And when it hugs these brackets, what it means is that we're going to be multiplying what's inside the brackets by -3. Now, the only problem with that, though, is if we're following order of operations, we can't take x and subtract 1 from x because we don't quite know what x is yet. So we're going to do this concept called distributive property, which is going to allow us to get rid of these brackets so we can kind of work our way down. So this is how it works. Essentially what you would do is you would take your -3, or what is outside of your bracket, and you're going to multiply it by what is inside both times. So that means that we're going to be taking -3 and multiplying it by x. And we're also going to be taking -3 and multiplying it by -1. So it looks like this. -3 times x is going to give us -3x. And then if we take -3 and multiply it by -1, well, a negative times a negative is always a positive, and then I'm just left with 3 times 1, so that is 3. And what you can see here is now I've eliminated that bracket, so I can actually continue the process of working my way down here. Let's do it right here as well so you can see what that looks like. So we have +8 outside, so we're going to assume that our when we multiply that things are going to be positive inside of here. So a positive times a positive x, 8 times x is going to give me 8x. And then I've got a positive times a -3. Positive times a negative is always going to equal a negative. So I have 8 times 3, which is 24. And you can see here I've also eliminated this bracket now as well, which is exactly what I want to do. On this side, you can see that there is no brackets. There are no brackets, rather. And we've got some combining that we can do here. We've got some x's and some x's here. So we're going to push those things together to try to help get rid of some of these numbers, because it's much easier to work with 2 numbers than it is to work with 3. And that's kind of the process or the concept behind combining things that are similar. So in this case, if we've got a group of positive 6x's and a group of negative 6x's, and we just push them together, we're left with a single x, because 6 minus 5 is 1, so there's one single solitary x right there. And then I can do nothing with this constant, so I'm just going to make it +7. Now, if you think about that on the other side, we can do the exact same thing. We've got a group of x's here. We've got a group of x's here. So why don't we just put them together? -3x's plus +8x's is going to give us 5x's. And then we also have some constants that we can put together. We've got 3 and -24. So if you add 3 to -24, you end up with -21. And then I'm just going to bring this down because I haven't used it yet. So +7. Now I want to pause for a moment and I want to look at what we've done here. Essentially what we've done is we've taken something that was significantly larger and we combined them. We pushed some things together to make something a little bit more manageable. And so instead of working with 1, 2, 3, 4, 5, 6 different types of numbers, or 6 different types of mathematical, well, they are numbers, 6 different types of numbers and variables and constants, we're now working with 2. I don't know about you, but I kind of like working with 2 as opposed to working with all of these. It just becomes a lot more easy for us to work through. And now we're left with nothing that we can do on this side in terms of combining, and nothing that we can do on this side in terms of combining. But what we can do is we can move our variable to the left, and we can move our constant to the right. And how do we do that? Well, again, we use zero principle to try to cancel things out. Keeping in mind that algebra is all about creating a balance, where if this was equal to this, if I did something to this side, I have to do the equal amount to this side in order to maintain the balance of it. I'll show you what I mean. So in this case, I want to move the variables to the left side of equals, and I want to move the constants to the right. So in order for me to do that, I'm going to have to subtract a single x to get rid of it on this side or cancel it out. And if I subtract x on here, I have to subtract x over here. So I'll rewrite that so you can see what it looks like. 5x minus 21 equals, and then I'm not going to do anything with this because it's canceled. And I'm just going to move down the positive 7 because I haven't done anything with that yet. And then I have 5x minus x. So if I had 5 x's and I took 1 x away, I'm left with 4 x's. 4 x's minus 21 equals plus 7. Now, very similar to what I just did with the x's over here on the right side of equals, I'm going to do the same thing with the constant on the left side and move it over here. How do I do that? Zero principle. I'm going to eliminate this negative 21, or zero it out, by adding 21. And much like I did with the x's over here, I have to move my 21 over to this side. So if I added positive 21 here, I have to add 21 to this side. That's going to cancel out these negative 21, and it's going to give me 4x is equal to 7 plus 21, which is 28. And now, if you'll notice, what I've started with here, I've moved from 1, 2, 3, 4, 5, 6, 7, 8, 9 different mathematical numbers to now just 2. That makes it significantly easier for me to solve what x is going to be. And all I've done is just push similar things together and use zero principle to cancel it out. So now I'm left with what's just called one-step algebra. There's only one step I have to do in order to figure out what x is. And that is just eliminating these 4 groups of x, because this question is saying if I have 4 x's together, they're going to be the same as 28. So what does 1x equal? Well, if I divide by 4, and then following the same sort of process and concept up here, I do the same thing to the other side, that leaves me with a single solitary x. And that's because 4 divided by 4 gives me 1, or one single solitary x. So I'm going to put this over here. That leaves me with an x. And it says that x is equal to, or the same as, 28 divided by 4. So 28 divided by 4 is 7. And that is how you go through distributive property and combining like terms. You move from something that is significantly larger and just push things together that are the same in order to solve your missing variable. And then just one last thing before I end this video. This x right here, if you would like to check your work, if you plug this x or this number into all of these x's, you will end up with the same number equaling the same side. So every single x up here has a value of 7. That's distributive property and combining like terms. If you are a little bit confused by it, then by all means, please drop a comment. I can create another video in order to kind of help you out. Please subscribe, like, share, so on and so forth. And thanks for tuning in.